Our first workshop today will be presented by Sarbani Maiti. Sarbani is the Vice President of Data and AI Practice at Virsa Technology. She has over 20 years of experience in various technologies, including cloud, AI, MI, and data analytics. In her current role, she focuses on developing data-driven solutions for healthcare, finance, and other industries. As an AWS community builder, speaker, and tech blog writer, Sarbani is dedicated to sharing her knowledge and experience with others. She was a speaker this year in April at the annual WIDS Bangalore conference, and we're so excited that she is joining us today. Sarbani's workshop is entitled How to Build Responsible AI Systems Using RAI Dashboard in Azure ML. She'll answer questions at the end, so please add them into that Q&A box as we go. And the link to code that's shared during the presentation will also be shared at the end of the presentation in the chat. So please welcome Sarbani.
Thank you, Jen. Thank you for this lovely introduction. And good morning, everyone, and good evening if you're joining from other part of this world. And I'm going to start my session. Okay, I'm going to share my screen. Give me a second. Okay, great. So in today's sessions, I'm going to talk about how to build responsible AI model using Azure ML Studio and Responsible AI Dashboard. My name is Sarbani Maiti. I'm working as VP Data Science at Virsa Technology. Okay, so to start with, let's look at what is Azure ML Studio. So Azure ML Studio is an integrated advanced data science machine learning platform on which we can build end-to-end model. We can prepare the data, we can build and train the models, we can validate, deploy the model, as well as we can manage and monitor the model in the production system. How to set up the Azure ML Studio, how to set up the Azure ML subscriptions. I'm not going to talk about in detail, but at end of the session, I'm going to share the link where you can see all the steps and you can follow, and you should be able to create your ML Studio using your own Azure subscription smoothly. To start with, on the prepared data side, so if I look at the Azure ML Studio, on the prepared data, we can see that several stages are available. Data labeling, as we know, data labeling is important for machine learning projects, then data preparations and data sets, which are prepared for the final model training. Let's look at the build and train models. The offering from the Azure ML Studios are a notebook where we can build our entire code. Then we can also use the CLI and Python SDK. So Python SDK, I'm going to use the Python SDK coding system in my demo as well, where you can build the notebook using our known Python libraries. And we have to incorporate few of the Azure ML libraries that we'll see when we look at the demo. Automated machine learning platform, AutoML, which is not part of today's workshop, but this is another interesting offering from Azure ML, where it's a kind of no-code system. They have a designer studio through which we can build the model as well. It has a nice integration with the Visual Source Code, GitHub. Drag and drop designer is available with the AutoML system. In the entire AutoML or in the Azure ML system, we'll see the two different stages very distinctly. One is the experiment stage, another is the UAT production and final deployment stage. In the experiment stage, we can build multiple models using multiple algorithms. We can use our different strategies. Multiple data scientists can work together, and finally, we can build several models. After that, we can choose the best model by looking at the model evaluation criteria based on our use cases. So that generally happens in the experimental phase. There are several open source libraries and frameworks are available in Azure ML Studio. Here, I'm going to use scikit-learn in this particular demo. The validate and deploy, which is a kind of integrated CI/CD pipeline through which we can deploy our model in UAT, and the UAT model, once tested and approved, can be deployed in the production. We can also create our final endpoint, batch prediction endpoint, or real-time endpoint. It can be integrated with the Azure Web Apps or any kind of other downstream system. Now, this is not, again, a part of today's demo, but we'll basically follow our model building strategy in terms of Azure Responsible AI Dashboard. Okay, quickly manage and monitor. This is again post-production stage where model is deployed, approved, and we start using the model prediction in production. Then we need to monitor the model in terms of data drift, concept drift, error analysis, auditing, cost control, security policies, and other production and policies which are applicable for that particular industry. So this is the current kind of screenshots from my Azure ML Studio, but we are going to look at when I'll open the demo in my Azure cloud system. So as we move on, we'll all look at that in the demo. Now let's look at what is responsible AI and why it is so important when we build the model. Responsible AI is an innovative methodology that prioritizes that safe, trustworthy, and ethical development, assessment, and deployment of AI system. So in summary, when we are building a model, the model outcome is actually disrupting human lives. We are using the model decisions in various sectors, starting from the banking, the healthcare, then the personalization of the recommendation system, and this particular outcome is actually impacting the human lives on day-to-day basis. So this is extremely important to understand whether we are able to trust that particular model, whether we are able to trust the particular decision which is made by the model outcome. Is this trustworthy? So this question is actually addressed in this responsible AI framework. Responsible AI is actually a broader umbrella. This is a framework. We can call it a framework when we adopt this framework in our entire AI ML system. This is recommended that we start incorporating the various aspects of the responsible AI, starting from the data collection to the data and model deployment in the productions. Even post-production, it is important to monitor all the different parameters which are part of this responsible AI ecosystem. To understand what is responsible AI and how can we measure or how can we implement that in this entire pipeline. Fairness. And when we talk about the fairness, we talk about the fairness in our data collection strategy, in the model, and when we are going to deploy the model and the final outcome. And all the components will be applicable in each and every stage of this AI ML system. Reliability and safety, privacy, security, inclusiveness, transparency, and accountability. Let's look at all of them one by one quickly. Responsibility AI, as I said, so we have already talked about this. Let's look at this, how Azure is helping us to develop a responsible AI platform. In Azure system, we will see there is a fantastic responsible AI library or module, which is giving us an end-to-end platform to develop a dashboard using the data, what we are using to build the model, and the model which will be built can be integrated quickly with this dashboard, and we can visualize each and every step, and it will be easy to understand. It's not going to throw a lot of technical jargons, but it's going to be easy to understand in simple English, because most of the time we present this kind of dashboard to our end customer or sponsor or other stakeholders who are not technical in terms of AI, ML, or data science technology. But they need to understand the model outcome. They need to understand how are we going to select the data? How are we going to select the features? What is the impact on a particular feature on the model outcome? These questions are always asked by the business partner or other stakeholder. And as a technologist or data scientist, it is our duty to respond to present it in a nice format. And there exactly, responsible AI dashboard is really good. So there are the different parameters. What we just talked about will be implemented in this entire dashboard. Now let's look at how. Fairness. AI system should treat everyone fairly and avoid affecting similarly situated groups of people in different ways. Okay, this is a, it's kind of a definition to understand that. So when AI system provide guidance, let's say on a medical treatment, we'll see that in our demo as well, or a loan applications or any kind of employment decision, they should make the same recommendations to everyone who has similar symptoms. If we talk about healthcare, if we talk about other applications like financial domain or employment, it should make the similar outcome for all the people coming from different financial groups, different professional qualifications, different ethnicities, different age groups, different genders. And how the fairness is implemented in Azure ML system using RAI Dashboard, we'll see that the fairness assessment component of the dashboard enables data scientists and developers to assess model fairness across all the sensitive features or attributes what we just talked about by looking at different cohort analysis. Reliability and safety. This is all the ML systems should be able to operate as they were originally designed. It should respond safely to unanticipated conditions and resist harmful manipulations. So this is important. So a lot of time we put a lot of focus when the model and the entire system is being developed. The moment it goes to the production, it starts producing the outcome and people get the benefit. A lot of time, the monitoring and tracking mechanisms are not enough, and we will not be able to understand when the model start giving us the bad outcome. In this entire system, we generally do not see any error like other software application system and enterprise applications. Once a model is deployed, it doesn't throw any typical exceptions or error in the log. So it is important to look at the model outcome and evaluation criteria. If it's going down the threshold criteria, we should look back to the data. We should look back other external factors. We should also look at the sampling criteria. And if it is required, we need to retrain the model. And this particular reliability and safety features are deployed in Azure ML Studio by using different cohort analysis. So we'll see in our demo how the cohort analysis help us to rely on a particular model. And if there is any error, we should go back and we should rectify the particular sample data set or the entire cohort if it applies. Transparency. It is crucial that people understand how those decisions were made by the model. As I said, model must be trustworthy. I should be convinced enough so that I will start using the model outcome. It will be integrated with other enterprise system. So once this is integrated with the entire enterprise system, it will start impacting the whole lot of people. So this is important. The transparency is always there. Nobody will like a black box model. Model interpretability and transparency is built using counterfactual what-if analysis, which is again a part of our demo. Now, apart from this counterfactual analysis using RAI Dashboard, there is another way Azure ML help us to increase the model explainability, which is called a explainable module, which is outside the RAI Dashboard. And this is not part of today's demo, but just to mention, if anybody is interested, the explainability model can be built separately using another module on the ML Studio. And this is also kind of touched upon here in the RAI Dashboard. Privacy and security. Whenever we build any system, it is extremely important we look at the data privacy and security of the system, because at the end of the day, it's going to be deployed in the production. And data privacy law is there in each country. And for each industry, each domain, this is important to understand. And all the policies will be applicable depending on the use case. And how it is achieved in Azure ML Studio? This is achieved by using the Azure Managed Security Framework. I mean, it's not only for the ML Studio, this is applicable for all the services and offerings which is there in the Azure cloud. Kind of like, first of all, we need to create the account. So there is an administrator for the entire cloud account system. The account administrator will provide access to the developers. Developers will be able to work only on the development system, what we generally call the experiment. And then once the model is ready, it is deployed to the UAT, and then it moves to the production. But generally, developers do not have access to the production, and or sometimes they do not have access to the UAT. A separate set of people generally manage the UAT environment and the production environment. That is again a part of the DevOps framework, which is kind of integrated with the ML system, which is called MLOps. We can restrict the access by using the different resource group for different department. Now, a model can be deployed for different department group, and different department can use the same model for their own set of data. Now, each set of data will be restricted for that particular department. So department A should not be able to see the outcome of the department B. So that way the resource group and endpoint API restrictions, everything can be managed by using the Azure Security Management System. Then we also create the private network. Incoming, outgoing network access management is done again through the network management system. Data is encrypted in transit at rest. We scan the vulnerabilities, and there are a lot of audit mechanism is available on the Azure cloud. And this is again, it's not only for ML, it is applicable for most of the Azure services. Accountability, the people who design and deploy AI systems must be accountable for how their systems operate. AI systems are not the final authority on any decision that affects people's lives. So as a ML people or AI ML data scientist team, we can create a model, we can tell the stakeholder or business or client or end user, okay, these are the features, 1, 2, 3 are going to impact the model outcome. But at end, decisions are made or accepted or approved by the end user or the stakeholder. Now, business can come back. It happens a lot of time. When we use the different features, we build a model. Model is a statistical model. End of the development, definitely it will come back with certain set of features with some importance value, because it's end of the day, some numbers are always assigned. But a lot of time it happens when we present that to the business. Business says, oh my God, this particular feature is not even exist in our general workflow. It might be there in the entire data set, but it's not important for us. Even if model says this is important feature, but it's up to the business people or the final approver whether they are going to accept it or not. So if they are not going to accept it, we need to again relook at the data. We need to work on the feature engineering stage. Again, we have to come back with a new set of features. Or there exactly, it's kind of an iterative process. And it takes a lot of time. It goes through a lot of development and experimental life cycles. And finally, we try to produce the best fit model for that particular use case. And this is again achieved through the robust MLOps framework. So DevOps, when DevOps is integrated with the ML pipeline, then we call it MLOps. And starting from the data collection strategy, deployment strategy, and finally, when we expose the model API to the end user or downstream system, everything comes under this MLOps framework. Who is going to own what piece of module? I mean, it's kind of data. Who are the owner of the data? Who is going to own the model? Who is going to own the UAT? Who is going to own the production? And finally, who is going to manage the production environment? Now, who is going to monitor the data drift? Who is going to monitor the concept drift? And who is going to, again, come back, take the feedback, and start the cycle again? So these things are generally strategized and decided even before we start the project. Okay, so now in this responsible AI dashboard, in this particular demo, we'll look at two different areas. One is the model debugging. Here we'll see the error analysis, data explorer, which is kind of an EDA. model overview, fairness assessment, model interpretability, and counterfactual what-if analysis. On the another notebook, which will tell us the business decision-making process by using causal analysis and counterfactual what-if analysis module. And how are you going to generate this dashboard? We'll be using Azure ML Studio. The various components will be used here. One is that tool component is that explanation to the RAI dashboard, inside dashboard. Now everything will be done through coding. I'm going to use the Python SDK code, and that particular sample notebook is given by Azure ML. And I would recommend always refer to the GitHub, which is recommended by Azure ML Studio and Azure ML team, because they do publish a lot of new libraries. They do change the library. So it's always recommended to use their, official Azure ML GitHub. And that is what I have given in my reference as well. The explanation, we'll first add an explanation module, then causal to RAI inside dashboard, and counterfactual dashboard, then error analysis, and finally we'll gather all the insights in the dashboard and we'll generate a scorecard, which is generally stored in the S3 bucket, and we can also download it. So basically, our dashboard is the framework is there. We'll start creating all the widgets through Python SDK code. But before that, we'll prepare the data quickly, we'll build a model, and we'll start the pipeline. And what are the different areas we are going to focus? One is that identified stage, where we're going to analyze the error in the different cohort of the entire data set. And we'll do our fairness assessment by look at few numbers. Then diagnose, here exactly we're going to do counterfactual analysis, as well as we do a little bit of EDA on the graph itself. And the mitigation part is not part of this dashboard, and right now that mitigation part is not integrated with the dashboard. So once we understand the error, once we understand the different analysis and result, then we have to mitigate the result using a couple of statistical method. But this is not part of this workshop today. Today we'll just focus to analyze the entire data set and the model by using this dashboard. And decision-making process will help us to take informed decisions, which will be backed by the data. It's not any random decision, so that we can explain it to anyone, whoever is interested to use the model outcome. Okay, let me quickly go back to my Azure screen. Okay, hope this is visible to everyone. Okay, so this is Azure screen. This particular Azure responsible, this is a particular resource group I created, and then I have created a Azure ML Workspace. Now, how to do that? I have already given a link, and step by step you can follow the process, starting from creating the Azure account. You can create the Azure subscription. If you are working under any administrative account, then you can create your own user group, resource group, or you can request your system administrator. They can create a resource group for you to do this demo. Another thing, this is going to incur some cost if you are using pay-as-you-go model or pay-as-you-go subscription. If you have a free subscription, you can use that. But if it is pay-as-you-go, then once the demo is done, I would recommend delete the entire ML workspace. Otherwise, it will start incurring cost. Now, another, if you see, even if you remove the Azure ML Studio or entire workspace, even after that, if you see there is a cost incurred, please raise a ticket using the help button here. So there is, you can create your support ticket where you can raise that my ML Studio or my particular resource group is still incurring cost, even if I have deleted everything. And generally they waive off, and they help us to find out why it's still incurring cost, and they help us to delete everything and clean your workspace. This is just kind of recommended before you start anything on the cloud. Okay, now as you see on the left hand side, you can see there are several tabs which is used to monitor the IAM access control, but this is not part of today's demo. I will quickly launch this ML Studio. So once your ML Studio, Azure ML Studio workspace is built, you will be able to see this particular screen. And on the right hand side, this is the studio URL link. So let me click on that. I'm opening a new studio here. Okay, it's coming up. Okay, so this is my ML Studio. You can see the link here. So this is a bit differently, ml.azure.com. It's not Azure portal. So this is the ML Studio. And here you will see all the components, whatever you have built, or once you'll create your new component, everything will be visible here. It's kind of a nice summarized dashboard view for your ML Studio. I can see all my recent components which are created under this ML Studio. And I have already created this 2 notebook. As I was talking about, one is to debug the model. Another one is created to take the decision. So as the name suggested, the regression model is used to debug the model and error in the cohort, and decision model will be used to take the informed decision. And we'll see a few graphs on the dashboard as well. Okay, so as it is done here, you can see some models are already built. Let's look at one by one. So here, this is the notebook. So as you see here, this is the home page here, and then model catalog. I'm not going to use that. Notebooks. So notebooks is going to give me the page. It's taking me on the screen where I will be able to create my notebook, or if the notebook is already available, I can upload the notebook here. As you can see, all the options are available here. So I can create a new notebook here. As you see, this is by default, it will create the user, and then one folder is created. And under this, I can create my new file. I can upload the notebook from my local directory, and that way I can work. So these 2 notebooks I have taken from the Azure ML GitHub, and I have created this folder. And you can see there are 2 folders are created. One is that decision making, another is the regression model debugging. And diabetes, this is the data set I'm going to use in this particular demo. This is the diabetes progression data of various patients, where we'll see various parameters which are generally measured in various sample, like blood sample or general vitals, physical vitals, and doctors try to predict whether a particular patient will be diabetic or not. But it is not actually binary classification, yes or no, but it is actually a regression model where we're going to predict the risk factor associated with each patient record. And that's the reason it is a regression model. And the score, if the risk score is high, we can say the particular patient is having a high probability to be a diabetic. Now, here you can see in this particular folder, all the models are created here, and I want to show you here. So here the notebook, I have already opened it. So this is the one notebook where we're going to see the decision making, and this is the another notebook where we're going to see how this regression model is generated. Let's look at it one by one. Okay, this is a big code, but don't worry. This code is available on the GitHub. Only thing we need to understand the different modules, and if it is required, we can change it to incorporate our own data. So these are a couple of standard coding practice what we have to follow if we are running any model or any notebook in Azure ML Studio. So first of all, we have to incorporate the Azure ML library. So this is the compute I have created. So how it is happening? So this is the notebook, but this notebook is not running until unless I'll attach a cluster or I'll attach one compute device with the notebook. The way the Jupyter notebook or any VS Code runs on our laptop, we need to put some kind of virtual environment behind this or on this notebook. So how to do that? So let's look at it quickly. So here you can see a compute device. So here is a compute, correct? So we can go to the compute and we can create a compute or virtual machine. It's nothing but a VM or virtual machine. And here you can see, correct? I have created 2 different compute to run 2 different notebook, and they are currently running and they are incurring cost. So again, you have to be careful. Once it is done, delete all the compute instances, whatever you have created. So this compute instance has some kind of a configuration, which is important to understand. Right now, this is when I was running the model. If you look at the notebook, this is a pure notebook, correct? I have used some of this is my credentials. You have to use your credentials, subscription ID, resource group, and workspace. And once this is done, we have to install Azure AI ML. This is the first package we have to install, and then we can start using all the Azure ML library, ML client, default Azure credentials. And this is the ML client library or function which will be used, which is kind of taking all the credentials, subscription ID, resource group, and it will help to create the workspace and model inside the workspace. Then this is the registry name. Now why it is required? So we are going to create a model which will be registered in model registry. So we'll see that how a model is created and registered in the model registry once this is running. Now here I'm going to accessing the data. So this path is already created here. So data, diabetes, regression, train and test. The strategy is same. We'll have a set of data. Then we'll create a training data and test data. And then training data will be used to fit the model and test data will be used to evaluate the model. Few things is important here. This ML table. Now, the data, whatever is used here in the CSV format data, but it has to be converted to ML table format. So you can see this ML table dot load is used to convert this train data to the ML table format, because Azure RAI Dashboard has some restrictions. It only takes ML table format data. It only takes the scikit-learn model, and model has to be built using ML flow template. The 3 things are important for the responsible AI dashboard, at least at this as of today, the version which is running in Azure ML. So now rest of this is a pandas data frame, but again test data is now converted to ML table. And this is a kind of data set. A quick look, you can see all are numbers. And one interesting thing, you must be asking that why age is like this. Now all the numbers are already standardized. So this sample data set which is used here is already kind of pre-processed. We are not focusing on pre-processing of the data. Data is already pre-processed and standardized. And standardized data, as you know, it's created with the total samples divided by the standard deviations and all, and it is applied on all the features. And this is the gender, age. Now these are all parameters. What I was talking about, BMI, value of BMI, BP values, S1, S2. These are all other parameters which kind of now coded. So S1, S2, S3 and all. Why? Y is our target value. And you can see there, you can see a big 3-digit number. So this is the score, a risk score, which is assigned to each record. And as you see, the 341, I would say this is a very high score. And this particular patient has a high probability to become diabetic. Now you can see a very low score here, 37, 70, and that way all the samples are taken. So there are total 353 rows are present in the training data set. And after that, the training data, input data is prepared. Now, here you can see a bit different code. So if you have, if you are working on any kind of cloud system, Azure or AWS SageMaker, they all have their own framework. And we need to follow that framework once we call the training script or inference script. So here, the training data is sent to that particular framework in this particular format, and all the parameters are kind of fixed here. And whenever we'll run any model in Azure ML, we have to follow these patterns. Same for test data. You can see, so here it's kind of a ML client dot data get. This particular library or function will take the data in this particular format. So there is a try and exception module is there, so that if there is any exception, we can show it on the screen. Okay, now model training pipeline. So here, so far we have been talking about how to extract the data, how to prepare the data in the Azure ML format. Now pipeline, we are talking about two pipelines here. One is the training pipeline, and then second pipeline will be triggered using the model, and it will create the final dashboard. So we are talking about, one is the actual training component, when the training will happen, model training. Now at this point, the compute should be at higher configuration. So right now, if you look at my compute version, it's quite low. This is a standard versions. This is the lowest one I'm using because my model is already developed. So I have already developed the model because it takes kind of 15-20 minutes, correct? Depending on kind of compute you are using. So if I use a very high end compute, it may take 20 minutes, or if I'm using a very lower configuration, it may take even more than 30 minutes as well. So I have already created the model. I'll show that, but the same code, you just need to shift and enter, and it will start running. When I run the model, at this stage, actual training component is happening. Generally, it happens on a higher configuration. But right now, model is created. I'm just using the model and I'm building the dashboard. That's the reason I'm using a very low configuration compute. And that way, you can always optimize the cost. Second pipeline will be developed here for the model registration. What is the generic flow? Once the model is created, through the training pipeline, model is registered in the Azure ML Registry. And where it is this created here. So on the left hand side, you can see all the MLOps component which are used in this entire ML pipeline. So as I talked about jobs, whenever we submit any job, it's kind of processing job, data processing job, or training job, everything will be registered here under this jobs. So let me open it here. So let's say our jobs are running, and I want to see which job is running, what is the status. Entire jobs, all the jobs will be captured here under this monitoring tag, and here we can monitor all the jobs. Right now I'm not running any jobs, so all of them are kind of, you can see, completed. So I have run several jobs here, and all are kind of registered here with the status, when it was run, and what is the duration of the job, and it's quite easy to monitor them. And here you can see it. And if anything is failed, it will be coming under the failed bucket. If it is running, so all the status you can see clearly. So as jobs are there, and we can also see the details of the job. So let me see if I'm looking at regression one. I'm clicking on it. So this the job was triggered earlier when I created that particular model, and I wanted to create that RAI dashboard. So you can see the job was created through this pipeline. So who has created this job? This particular pipeline. If I click on the pipeline, I'll be able to see the pipeline details. Okay. So look at this. This is a very nice graphical representations of all the modules which were running during that particular processing. So if you see here, here is the model started, correct? So model output, and this is the data output. So there are two data sets we have used. One is the training data set, one is the test data set here, and then all the output model data set are fed to this RAI Insight dashboard constructor. And this particular model was created from training job. So right now we are looking at the responsible AI Insight job, which is now triggered here. And then you can see how it is working. So this Insight dashboard, you can see the explanation. So all the modules what we were talking about earlier, all the modules are getting created here. So you can see the explanation dashboard module is created here. Then it will trigger the counterfactual module. Then it's created here, error analysis. Then all of them are fed into the final insight dashboard to create a consolidated view. And on the right hand side, it is continuously taking the data. And we'll see once the dashboard is created, we can actually play with the data dynamically on the dashboard. It's a dynamic dashboard. And then we can finally, it will create the dashboard on which we're going to click right now. And then it will also create a scorecard. It's kind of a PDF format of the dashboard so that you can send it to the other team and all. So quickly, so this is a kind of pipeline. And this pipeline is generated here in this particular training pipeline model. So all the pipelines will be created by this code. I'm sorry, there is a power cut, but yeah, my screen is visible, hopefully. Okay, and as this is done, this is a kind of model is getting created. This is the main code. This is a big code, as I said. Here the model will be registered. Now where the model will be registered? So once the job is created, job is successfully completed, we can see the model is created under this model tab. So this is my model registry screen. Here you can see all the models which are created by the jobs will be registered here. And once model is created, after that RAI Insight dashboard is triggered. Here you can see two models are created. As I said, two notebooks, regression model and decision notebook will create the decision model. Type of the model, as we have seen in the code, ML flow type. And we can also see the details. So flavor, this is another important Python function and sklearn flavor. Okay, and Python version, you can see flavor sklearn. This is important for RAI dashboard. We cannot use other flavors at this moment. ML flow type. Okay, and this is the model artifacts, and all the model artifacts will be stored in the Azure blob storage. And here is the path. So you can also kind of download the entire model and you can run it in your local machine as well. But currently we are not looking at that. So model.pickle is created. Okay, now let's go to that notebook again. Once model is created, this is called model registry actually. And then if we go to this model artifact here, and you can, let's say, create, let me just close this compute. So here, if I click on the, let's say first look at the regression model. In this particular model, as we have already attached all the responsible AI code here, you can see this is the pipeline, all are done. Now here we are creating the RAI Insight. Once model is created, this particular Insight module will be attached with the model, and that we can see here. Let me close that pipeline now. Here. So you can see a couple of tabs are already there. If I click on the responsible AI, and if this particular notebook code is ran successfully, you can see this is the current version of RAI built-in components is done. Then we can go back to the UI and our portal, and we can see this dashboard example will be created. So all are linked. As the notebook progress, you can actually track everything on the Azure portal. And if I click on this Azure RAI dashboard example, and you will come back here. So you can see this is the regression model and this is the RAI dashboard which is created. Now look at it quickly. We'll look at it. So let's explore what it is created. This is created a cohort analysis. We can use that particular feature here, how to interpret that. You can see this is a tree map. Now all the nodes, let's click on this node. This node is telling me total count 89. If you see the hover, and here is a total count 89, that means this particular cohort is created with total 89 samples data. Total 89, we saw there were 300 records were used for the training, but right now we are focusing on 89 sample data on which we are going to test our dashboard. So this is called all cohort data. No prediction filter, nothing. This particular node is giving me 100% error coverage because it's a all data. So in all the errors which are created by the model, it's error coverage, correct? Prediction and difference between prediction and actual value, all the mean square error and all, which is part of regression model analysis or how to evaluate a regression model. So this error coverage is 100%. And what is the mean square value? 2985.23. Now, if I click on this node, now I'm trying to create a path. So what is that? It is trying to create different cohort within the entire data set and trying to compare the error between two cohorts. And that is done by calculating the distance between different error values. This particular cohort, how it is created? Age is less than equal to 0.02 filter. Again, this is the age standardized value. So don't get confused with why age is this kind of point value. So it has some value, backed by some value. And I'm putting this filter here, less than equal to 0.02. This is the prediction path filter. So definitely my cohort has now gone down to 57. So this is a sample, subsample or subset of the entire 89 record. And here you can see this particular sample or subset is throwing error as or showing error as 3623.44. So definitely error has increased. Coverage is 70%, but error has increased. Now I'm clicking on another path. Okay. Now I'm applying two different filters. Age is less than 0.02 and S4, which is another feature greater than equal to 0.02. This particular path is now impacting 25 samples and error is 200.46. But interestingly, this error is still, not the highest, but highest value is here. So my concern is this path. I should be worried about this particular cohort where age is less than 0.02 and S4 is greater than minus 0.02. This cohort is error coverage is 47%. Number of records, you can see it's very less, correct? 32. Because my total record is less. That's fine. But the error is quite high, 4891. Now, this cohort is important to analyze here. Now, this is my temporary cohort analysis. So this is a temporary cohort. I can also save as a new cohort. So I click on it to look at it. This entire cohort, I can select. I can just say demo widths. I can save it. Okay. So now if I switch my cohort here, and you can see all the cohort are listed. So I was creating a lot of different demo cohort and all I was trying to test. So now you can see demo widths is created here and I can apply it here. But interestingly, actually it's kind of limitations. This particular graph, you cannot apply it again on the subset what I just created. The entire graph will always be applicable on the total data. So let me just put it back as all data. But I can also apply the temporary filter by clicking. If I click on this node, it will highlight the path. It will create this temporary cohort. Okay, the temporary cohort is created and it is now open for analysis. So one thing is that let's look at the data and what are the difference between other cohort. So this temporary cohort, you can see sample size is 32. Here you can see the cohort wise analysis. So it's kind of picking up different sample and it is completely driven by that use case. I'm just doing it a bit randomly, but depending on the use case, we can create very intelligent cohort analysis. So, and we can clearly see absolute error, what is the mean square analysis value, what is the mean prediction, and we can actually see where exactly I should concentrate if I'm doing a model debugging or error analysis. There might be a case that sample is chosen wrongly. The filter criteria is completely different. Data was not correct. Probably the source of the data of that particular cohort is not correct. So many things can be diagnosed by looking at this data. Again, another analysis is giving me the target distribution. Look at it. So temporary cohort is looking at, if you look at it, kind of target is our risk score is quite high. Temporary cohort error is high, as well as kind of it's lying on the upper side of the prediction or target value. It's kind of risk is showing quite high on this particular temporary cohort. So these are kind of cohort 1, 2, 3. So I just put some filter value here, and they are kind of look similar. Demo 2, I create another small cohort. Let's say this is another cohort. You can see the prediction is quite low. I mean, risk score is quite low in this particular demo, and we can also see whether this, sometimes it may happen that prediction is low, like it's kind of probably it's showing a lot of false positive. Because prediction is low, that means it's target 0, and error is high. So even if it's a false, that means it's showing a lot of false positive, and we need to look at this particular sample. It might be driven by some particular demography. It might be driven by certain age group. It might be driven by certain ethnicity. You never know. And there exactly we can look back and see if any kind of bias is introduced or not. It might be the case that we have only looked at a particular demographic data. We have not incorporated demographic B, but we are trying to predict the demographic B using the model which is trained on demographic A. This is not correct, because demographic B might be having a completely different characteristic or features important. So this cohort analysis will help us to find out this kind of biasness in the data. And this is another data analysis. This is again an EDA. Generally, we do this. We can do an error analysis on a particular feature. So we have selected, so all the features can be selected here. I can select the feature BMI, or let's say S1, apply, and I can see the graphs and natures are all different. I can see I'm doing an error analysis. So for this particular parameter, for this particular range, this is the error. But in this particular range, I can see error is quite distributed, and it's kind of lower, upper half, and we can do all the box plot and aggregate analysis. Individual data point and scatter plot, I can also do this. This is a scattered analysis, and it's simply just by clicking the different buttons, I can do all such analysis. Feature importance, we all know, generally we do the feature importance once the model is used to predict some value. What all features are important? Again, cohort by cohort analysis is done here. Here you can actually, we can compare each cohort. So S5 is kind of important for most of the cohort. And then BMI comes, the next feature is kind of similar. Some here and there, some kind of spike here in the red. Another for one particular demo, one particular cohort, BMI is quite high. So kind of trend is similar, I can see. So S5, BMI, BP, and gender. So these 4 are quite important features, and they are definitely quite sensitive features. I can see that is the gender and all. So with this, we can also take a lot of decisions. And this is another feature, another way to present, like feature importance, how the feature importance is impacted by a particular feature value. So this is again can be done here as an individual feature importance. We can also do. So each feature, how it is impacting the model prediction. This is the aggregate. So overall, how all the features are impacting the outcome. Then we can also look at each and every individual feature if we interested to do that kind of analysis. Okay, so now this is a counterfactual analysis, and this can be done in other way as well. So this is available in the decision model as well. So let's look at the other one. So this is helping. So as I said, this regression model will help us to find out the error in the data cohort or different sample of the data. It will help us to find out any bias introduced in the data or not. Now, decision-making part will help us to take the final decision. Model is created, model outcome is generated. Now what? So let's look at how model is behaving. Model performance is important. So for regression model, generally we look at the mean absolute error or mean squared error, error values. And here I have created another small cohort by some just random filter, and just to see how the cohort analysis or 2 different cohorts are compared against different error value. Again, target analysis is done, target distribution. Sometimes it's important to see how the it should not be the case that we have taken a sample of the data for training where most of the targets are kind of non-diabetic. It's kind of, again, it's imbalanced data. Generally, imbalance actually, into a lot of time, imbalance introduce a lot of bias in the data set. And that bias is actually impact the final outcome of the model. So that will help us to find out whether my predicted value is kind of balanced or it's skewed on the lower side, or the positive side, or on the negative side. Generally, it's not happened because diabetes could be kind of lesser number of patient. Data analysis, again, it's done here. Again, the chart, and we can do all sort of data analysis. Now, this is important, counterfactual analysis and how we can take the decisions. So this particular data, let's say I'm taking one data point. This is all the sample data or patient record, I would say. Let's say this is, I saw one, 43. And here, I am changing that value to the predicted value, because that is what I want to see, what is the predicted score of that particular patient. So 43rd, this particular sample or patient is showing me the predicted score is 270. This is quite high. Let's say doctor said 120 is kind of a good value. So how can I reduce that score? So if we look at the doctor or patient, they would be interested to know how can I reduce this score by changing the value of one of the important feature. So this is counterfactual analysis. By changing the important features, how can I impact or how can I make changes in the model outcome? So this will help us to do. And by looking at this next graph, you can clearly see the S5 would be our feature of importance, because if I reduce this value, it will impact the model outcome. It will actually, now model outcome can be positively impacted or negatively impacted, and this we can check here. But let's say I look at this particular C. So here you can see the predicted value is Y value is kind of decreasing. And if I look at this particular sample,
Hey, Sarbani, I'm sorry to interrupt you, but
I know.
we're almost out of time.
Yeah, I know. So this is the kind of analysis that probably we can do with the counterfactual. This is another way, like this particular index, this is the particular feature, and this is the treatment value, how this is going to impact the final outcome. So I think I'm almost done. And once you create it, you can play with the data dynamically on this dashboard. And everything is written very clearly on the dashboard itself to understand the interpretation of this particular data. Okay, with this, I'm going to close my session. And right now I'm open for question answer. I know we do not have much time, but yeah, I'll try.
Awesome. Thank you. Well, thank you so much for this really interesting presentation and talking to us about responsible AI, which is so important, and it's so neat to see how this can be implemented. So if you would be open to sharing, yeah, I see you're copying the code now. So awesome. Thank you. So somebody's going to put a link into the chat that will take you to the code if you would like to check that out. And then also the recording of this session will be available on YouTube next week. We do have a few questions. I don't think we're going to have a chance to get to all of them. So Sarbani, if you open up the Q&A box on Zoom, I'll try and ask one, maybe if we have time, and then maybe you can type an answer to some of the other ones if you'd be open to that. So one, just to kind of get to the code question. So one person has asked, where's the source of this training and test data set, since we're not reading them from our local machine? So maybe you can answer that one live, and then
it is available
the rest
on
of them
this
you
link.
can answer.
Yeah,
okay, so it's available on the link. Okay.
So on the link, you can see all the different GitHub and data set. Everything will be available on this particular link.
Awesome. Thank you. Okay, so that's where you can access the data. And let's see, there's a couple questions about the differences between Azure ML and Databricks, and then a difference between AWS and Azure. I'm not sure if that's a short question, but if there is an easy answer to that one, maybe we can answer that one live too before we go on to the next presentation.
Yeah, so quickly, Azure ML and Databricks. So Azure ML is an end-to-end machine learning platform offered by Azure Cloud. Databricks is a separate product company, but Databricks is not only ML Studio. Databricks is an end-to-end data analytics, data engineering, as well as data science ML platform. So Databricks is a separate company, but it can be hosted on AWS as well as Azure as well as on GCP. So they have a good tie-up with all the three clouds. So sometimes we need to take a decision between Azure ML versus Databricks. Databricks is basically based on PySpark for big data analysis. So they have a node and cluster node. So you can actually run multiple machine learning training threads by using multiple cluster, and which will definitely faster your performance if you are processing loads of data. It's a big data system. So, but if your data is not big data, probably ML Studio will be a better solution, because Databricks would be a bit costly. I mean, but yeah, it's totally depends on your use case. But basically, Databricks is for big data analysis. It's based on PySpark. You can have a Spark SQL. All of them will be available in Azure ML Studio as well. But yeah, it's just some of the features probably depends on the use case.
Awesome. Well, thank you again, Sarbani. Thank you so much for your presentation. Thanks for taking the time to answer a few questions. As I said, if you are able to stick around for a little bit longer, I know it's quite late for you, but if you're able to stick around for a few minutes and type any answers to the questions in the Q&A box, we'd really appreciate it. And thank you again.
Thank you. Bye.
Bye.
Thank you, everyone.